So here we're going to look at finding the minimum and maximum and then the characteristics of the parabola using that. Okay. So find the minimum or maximum value of the function, describe the domain and range of the function, and where it increases and decreases. Okay, so let's start with the minimum or maximum. Now, so a parabola is either going to be opening up or it's going to open down. Now, if it opens up, it's going to have, the vertex is going to be the minimum. And if it opens down, the vertex is going to be the maximum. All right. And you know whether it opens up or down by the A. So if the lead coefficient is positive, it's going to be positive and smiley. If it's negative coefficient, lead coefficient, it's going to be frowny, right? It's going to open down. Okay, so just keep that in mind. Positive, it'll have a minimum. Negative, it'll have a maximum. All right, so let's find the, so let's look at the first one. F of x equals 4x squared plus 16x minus 3. So we know that because this one is positive, that it's going to be opening up. So it's going to have a minimum. Okay, now let's find the vertex. So we're just finding the vertex, basically. So let's label our A, B, and C. A is 4, B is 16, and C is negative 3. Let me plug it into the formula. X equals negative B over 2A. So negative, and then just plug in the B and the A. Negative 16 over 2 times our A is 4. And we get negative 16 over 8. And that becomes negative 2. Now if we, that's our x of the vertex. Okay, this is an important one to know. And now we want to find the y. So remember from last time, you just plug that in to find the y. So I'm writing the original equation, the original function. Notice how I'm leaving the x's blank because I'm going to substitute negative 2 for them. So negative 2, parentheses negative 2, parentheses negative 2. And those are multiplication, those parentheses. So we have negative 2 squared first, square it first, and then multiply, PEMDAS. So we get 4 times 4. So negative 2 squared is 4, positive 4. And 16 times negative 2 is negative 32, minus 3. And we get 16 minus 32 minus 3. So 16 minus 32 is negative 16, minus 3 is negative 19. Ooh. Okay, it's a good thing we don't have to graph it because that's a pretty small number, right? But this is also an important number when we talk about the range. Okay, so that's our y. All right, so we have our x, we have our y of the vertex. Let's write that down. Vertex is negative 2, comma, negative 19. All right, it's important to note. Okay, so, oh, sorry then. So this negative 19, that's also our minimum. Minimum. Ta-da! All right, and we know it's the minimum because it's positive. Positive, so minimum. It will have. It's Yoda. Okay. So describe the domain and the range. So the domain, those are the x values. So what we want to do is we want to take the x's, and actually for quadratics, it's always going to be all real numbers. All real numbers. And because it's always going to go to the left, and it's always going to go to the right forever, right? Let me focus. There we go. So that's why the domain is all real numbers. Now the range are the y values. Okay, so that's where our y is going to come into play. So the way you write this is your y of the vertex, sorry, that's not right. It's going to be y is either greater than or equal to, or it's going to be y is less than or equal to. Okay, it's going to be greater than or equal to if it's opening up. Okay, which this one is. So it's going to be minimum, and it's also going to be greater than or equal to. Now it's less than or equal to if it opens down, which is when we have a negative, and we'll see that later. Okay, so it's going to be y is greater than or equal to, and then the y of the vertex. It's that simple. So y is greater than or equal to negative 19. That's it. So this is saying above negative 19, right? It's just going to keep going up. That's where the graph is. All right. So that's the domain, that's the range. Now let's find where it increases and decreases. Now again, this is where we use the fact that the lead coefficient is positive. Okay, since it's opening up, it's going to be decreasing, right? It's going down. If you go from left to right, it goes down to the vertex. So decreasing to the vertex, and it's going to be increasing from the vertex. Now let me show you what that looks like. Okay, so let's do the decreasing first. When it's a positive lead coefficient, when the A is positive, all right, what you want to do is you just want to put x, it's always going to be x. Okay, also for y, it's going to be x. Oh, sorry, also for increasing, it's going to be x. And we're going to put, when it's positive, it's going to be x is less than or equal to, sorry, less than. So that means to the left of, and then the x of the vertex. Okay, so basically it's just going to be x is less than our x of the vertex was negative 2. So negative 2. Ta-da! And increasing, when the lead coefficient is positive, like this one is, it's going to be x is greater than, or the x's that are to the right of, and then the x of the vertex. And that's it. Okay. So we'll see one where we have a negative as well, so don't worry. That's it. So this one is going to go a little bit faster. Let's label. A is negative 1, B is 5, C is 9. Let's put a line so I don't get confused. There we go. Now I'm not confused. So let's plug those into x equals negative b over 2a. So we have negative 5 over 2 times, and we have a fraction. No, Oh well, it's okay. So we have negative 5 over negative 2, which is just positive 5/2. All right, circle it just so that we can keep it so we know, okay? So we remember. So vertex is 5/2, comma. All right, now let's find our y. So we're gonna write down, oh sorry, g of x, my bad. G of x equals negative, and then x squared, negative x squared plus 5 times x plus 9. And again, I left those x's blank because I'm going to fill them in with the 5/2. Hey, all right, got a fraction. Fractions are fun. And when we square this one, we're going to get 25. 5 squared is 25, 2 squared is 4, so negative 25 over 4. That negative is on the outside of the square, that's why it wasn't affected. 5 times 5 is 25, divided by 2, plus 9. And now we want to get a common denominator, so it's going to be 4. So we multiply this by 2, and this by 2. And we get 50 over 4. And here we want to put a 1 underneath there, and we're going to multiply that by 1 times 4. So we have to multiply the top by 4. And we get 36 over 1. So negative 25 over 4 plus 50 over 4 is going to give us negative 25 over 4, negative 25 plus 36. So basically 36 minus 25 is going to give us 11 over 4. Why is that a 1? Ta-da! Okay. Yay, fractions. So that's another important one. That's our y equals. And the first thing that we need is either a maximum or a minimum, since this is a negative. So that means it's going to be a maximum. All right, so that's our maximum. 11 over 4. Ta-da! Now let's do the domain and range. Again, domain, so nice. It's always going to be all real numbers. All real numbers. And a range. Okay, so for when the a is positive, its y is greater than or equal to the y of the vertex. When the a is negative, it's going to be y is less than or equal to the y of the vertex. Okay, and that's because it's going down. Okay, so it's all the numbers below that y. So y is less than or equal to, our y of the vertex was 11 over 4. Ta-da! And now we talk about the decreasing and increasing. All right, so since this one is going to be opening down, oh sorry, I should put the less than or equal to. Since this is going to be opening down, all right, it's going to be, as you go from left to right, it's going to be increasing. Increasing to the vertex and decreasing from the vertex. All right, so decreasing, so it's going to be x again, x and x. Now we need to know whether it's going to be less than or greater than. So if we look at this, it's increasing to the left, right? So for increasing, when the a is negative, it's going to be x is less than the x of the vertex. And for decreasing, it's to the right of the vertex. So it's going to be x is greater than x of the vertex. That's it. So we just write x is greater than, our x of the vertex was 5/2. Bada bing, bada boom. And for the increasing, x is less than 5/2. Ta-da! Oops. There you go. Okay, so notice that pattern. When it's positive, when the lead coefficient, the a is positive, decreasing is less than, x is less than, increasing is x is greater than. When the a is negative, it's decreasing is x is greater than, increasing is x is less than. All right, now let's look at this graph. Graph the function labeled the x-intercepts, vertex, and the axis of symmetry. So this is in X-intercept form. All right, are you going to see this much? You might. Not too much, not as much as standard in Vertex, but it's fine. When you take physics, you will. So let's look at this. All right, so here, what they give us is they give us the x-intercepts. So here, we need the p. And remember, if it's inside the parentheses, you gotta think opposite. So our p is -2, and our q is opposite of -4 is +4. Ta-da! So these are the x-intercepts. Okay, what does that mean? On the graph, we just put a point at -2 on the x-axis and +4 on the x-axis. -2, +4. Yay! Now we have to find a vertex. Okay, how do we find the vertex? We need a point that's in between, in the middle of those two. So what we're gonna do is we're gonna do the x of the vertex is, it's the average of these two. So p plus q divided by 2. P plus q divided by 2. Hey, okay, so -2 plus 4 divided by 2. It's going to give us -2 plus 4 is 2, divided by 2 is 1. So that means our x is 1. We're going to plug that. We have an x, so whenever we have a value and we have an equation, we plug it in to find the other one. So -3 times 1 plus 2 times the quantity 1 minus 4. So I got that from the original. All right. And then 1 plus 2 is 3. 1 minus 4 is going to be -3. It's a lot of 3's. So -3 times 3 is -9 times -9 is going to give us positive 27. Ta-da! So our vertex is 1, 27. And whoo, look at this. So our graph only goes up to 4, so we're going to scale it. Okay. So we need to go all the way up to 27. I have 4, so let's go by, I don't know, 9? Sounds good. 9, 18, 27. Looks good to me. And if you want, you can do a 36 there as well. So you put a point at 1, 27, and that's it. So vertex, oh wait, did they need axis of symmetry? Okay, axis of symmetry. remember from last time, axis of symmetry is just x equals x of the vertex. So that's just x equals 1. Okay, what does that mean? Let me draw the parabola first. Ooh. And ooh. Looks good. That just means we're going to draw a vertical line right down the vertex. So x equals 1. And that's our graph. And is it right? Yeah, look at this. 1, 2, 3. 1, 2, 3. Looks good.